this on YouTube right now?
It's not on YouTube right now. No, I don't have a magic like direct feed into YouTube. Yeah, you gotta actually.
You put these on YouTube?
Yeah, he puts it on the YouTube.
I thought you just put it on
What's
the
your name?
Kendra.
No, I've been videotaping it for the last couple of weeks.
412. What's your YouTube name?
Mr. Aldrich 314.
314?
Yeah.
Is that March 14th?
No, it's pi.
March 14th. Friday though. That was close.
Okay, yeah. Okay, so now we are going to take a look at all kinds of different rational functions in our graph. We were just looking at specific kinds in the last section that were just these reciprocal functions. Okay, so we're going to start by looking at three different types. First of all, you need to know what a rational function is. And we talked about this the other day. A rational function, you should think fraction when you hear the word rational, because a rational number is any number that can be expressed as a fraction. So a rational function is two functions being divided by each other. Okay? So q of x over q of x. So in this case, x squared over x squared plus 1 is a rational function because there's a function on top and there's a function on the bottom. Okay? So we're going to look at three different types of rational functions. This one right here is called, yeah, really, you don't know what this one right here is called a continuous function because you could take and put your pen or your pencil on the left side of the graph and draw the function all the way to the right side of the graph without ever lifting your pencil off of the paper. Okay? So this function is considered to be continuous. There's no holes, there's no breaks. It continues from one side of the graph to the other. Does that make sense? Okay? This function right here is discontinuous because you will notice that there is a hole in the graph. Okay? So that hole is not really as big as it appears on my graph here. I made it really big to emphasize it. That hole is only the size of a point. And if you remember from geometry, a point is actually infinitesimally small. Okay? So it's really, 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 really super tiny. So if I didn't put that circle there, you wouldn't be able to see it. Okay? So I made that circle there to emphasize that it is a hole in the graph. Oh. So this is discontinuous because if I tried to draw from one end to the other, I would get to there, and then I would be stuck because there is a hole in the graph. Okay? We're going to go back and forth between these, so don't panic when I turn the page and you haven't been able to copy it down. This graph right here is also discontinuous. Right, for the same reason. But you should be able to recognize that this discontinuity in this graph looks very different from the one in the other graph. Do you see that? Yeah. Right, it doesn't have a hole. This is one of the graphs that we were talking about yesterday and the beginning of class today. It's discontinuous because if I start over here and go this way without lifting my pencil, I'll never end up on this side of the graph, but it has a very different discontinuity than the other one. Okay? So, what I'm hoping that you understand from that is the difference between a continuous function and a discontinuous function. Okay? Do you understand the difference between a continuous function and a discontinuous function? Right. Okay. So you have no questions on that. All right. Now we need to understand why. Okay? And actually, let's stick with this one right here. Why, we talked about this a little bit yesterday, is there a break in this graph right here where x equals 2? Why is there a vertical asymptote at this graph at x equals 2? What? Because what? Because the thing on the bottom Okay? If I plug in 2 on the bottom, Courtney, please stop. If I plug in 2 on the bottom, what will you get? 0. Okay? And as we talked about yesterday, can I divide by 0?
No.
No. Okay? So that's why x equals 2 is a discontinuity there. Let's look at this right here. What is the x value of the discontinuity in this graph?
2.
Negative 2. What happens if I plug in negative 2 to the bottom? I would also get 0. Okay? What is different though about this discontinuity and or this function here and this function here, which makes the graph look so different? It's the multiplication on the top, and more specifically, if I asked you to simplify this function right here, what would you do?
X plus 5 or x plus 2.
I wouldn't FOIL it.
No.
I would cancel out the x plus 2's, okay? Because an x plus 2 on the top and an x plus 2 on the bottom cancel each other out. So since I can do that, this is called a removable discontinuity, okay? Because I can remove that discontinuity from the function by canceling it with the thing on the top. Okay? That's called a removable discontinuity because now I have rewritten the function as x plus 3, which would be the exact same thing as this. For every number that I would plug in, if I plugged in 1 for x into this function, and I plugged in 1 for x into this function, I would get the same thing. And if I plugged in 27 for x in this function, and I plugged in 27 for x in this function, I would get the same thing. Okay? There's only one number where I would get a different answer. What is it?
1, 2. Negative 2.
Negative 2. If I plug negative 2 into here, what do I get? 1, which would fill that hole. If I plug in negative 2 for this, I get no solution. Okay? So these are almost the same. Okay? So it's a removable discontinuity. Yes.
What if they don't cancel?
Okay, if they don't cancel, like this case over here, can I cancel an x plus 4 and an x minus 2? Then you get this kind of a discontinuity, which is called, are you ready? This is crazy. It's going to blow your mind.
Non-removable.
Non-removable.
Oh, dang.
Okay? And sometimes this will be referred to as an, wow, infinite. Had an extra I in there. Sometimes this will be referred to as an infinite discontinuity, okay? But the main idea for you is this one can't be removed because the thing on the bottom won't cancel. The other one can be removed by canceling it out, okay? So you've got continuous and discontinuous, and you've got removable and you've got non-removable, okay? All right, so let's play. Wait a minute. Okay, so what we're going to answer, what the questions that you're going to be asked to figure out are,
It's an x squared x squared.
does that function have any discontinuities?
Yes.
If so, where are they?
Right there.
And what type are they? Okay,
Removable.
so does it have,
Yes.
I don't really care what the questions actually ask you in the book. Here's what we're figuring out. Discontinuities, yes or no. Where and what kind. Okay? So does this, when I said does this have discontinuity, a lot of you said yes. Why?
Yes, sir. X plus 3.
Because the x plus 3 can cancel?
No, the 3.
No, the 3's can't cancel. You can only cancel when you are multiplying. Okay? And so that means that I have to change the bottom into, are you ready? Oh, Katie, don't let him do that to you. Distract you like that when you should be learning. Breaks my heart. Don't do that. Okay, this is your life for the next probably week and a half. Okay? I need to take this bottom and I need to factor it. Okay? Because for the very reason of you can only cancel things when you are multiplying. So you cannot go the 3's cancel because there's one on top and one on the bottom because those are being added. So you have to turn this into a multiplication problem by factoring. So two numbers that multiply together to be 3 and add to be -4 are -3 and -1. Okay? So now, discontinuities, yes or no? Yes. Where? What numbers can I plug into there that will give me a 0 on the bottom? 3 is one of them, and 1 is the other one. Okay? So yes, it has discontinuities at x equals 3 and x equals 1, because 1 minus 1 is 0. Okay? Remember, inside parentheses, it's always opposite. So
There's
x,
no 1 on top.
I don't care about the
It's
top.
just x.
It's the bottom. It's all about the bottom.
So 3
I
minus
really don't
3.
get this.
What don't you get?
Why is it just because the numbers involved?
Yeah, because I can't divide by 0, right?
So we're just saying like this.
Yeah, so if I plug in 3 for x on the bottom, 3 minus 3 is 0, and then I would end up dividing by 0, and I can't do that. Okay? Same thing if I plugged in 1 for x, 1 minus 1 is 0, and then I'd have, so that screws me up.
Oh, so you put a number in it?
Yeah. Okay? So I have discontinuities at 3 and 1. Okay? What kind? How would I remove it? I got a removable, I got a non-removable.
Because you can x plus 3 next time.
No, because they're not the same, so I can't.
Non-removable.
Okay? So since this is a plus and this is a minus, that means that they are non-removable. Okay? So those are my 3 answers. Yes, there are discontinuities. They are at 3 and 1, and they are non-removable. Kayla?
How did you get this?
Okay, the 3 and the 1 I got from looking at the bottom and seeing what number, if I plug it in for x, will it give me 0. And since 3 minus 3 is 0, okay, and 1 minus 1 is 0, that gives me 3 and 1. Okay? All right?
I'm bad at factoring.
You're about to get good at it. Okay, same 3 questions.
Okay, here we go.
Discontinuities, yes or no?
No.
Why?
Yes, there it is. It's like the same as the last one.
What number would I plug in for x to make the bottom 0? 1 squared is 1 plus 1 is 2. Negative 1 squared is also 1 plus 1 is 2. 0 squared is 0 plus 1 is 1.
There's the.
Is it a fraction?
Nope.
It has
Because
discontinuities.
what you're looking at is you need x plus 1 to equal 0, right?
Okay, so now
Okay,
you're factoring.
so if I subtract, I can factor it, but I don't have to. It's easier to just, in this case, because there's no middle term, to just subtract 1.
What was the
Okay.
difference between that one and the last one?
The last one had
Oh,
4x in the middle. Okay. Square root both sides. So x equals the square root of -1, but what's the square root of -1?
1.
Yeah, it's I. It's imaginary. It doesn't exist. Okay. So that means there are no discontinuities.
Oh my gosh.
You didn't know that was a kid. Yeah, you knew.
Okay? So since the bottom never equals 0, that's a continuous function, and our work on that problem is done. Okay?
So if it doesn't.
Don't have to go any further, because obviously if there's no discontinuities, I'm not going to be able to say where the discontinuities are, because there aren't.
Nice.
So if you have to equal 0 on the bottom?
Right, so we're looking for making the bottom equal 0. Okay, one more.
No.
Uno más.
You're not going
Is there 2 minutes left in class?
No.
There's 7.
For reals?
Yeah.
Okay, discontinuities, yes or no? Katie, discontinuities, yes or no? Katie,
Yes.
Katie,
No.
are there discontinuities, yes or no?
Yeah.
Where? What do you mean the bottom? I need an x value
Right, because it needs to equal 4.
at x equals 4, right? Okay, so yes, there's a discontinuity at x equals 4. Okay, removable or non-removable?
Removable.
How do you know?
Because they can't have
Okay, I have to factor the top. You guys can't cancel the -4s. You got to get that out of your head. I can only cancel when it is multiplication. So I'm going to take x squared minus 3x minus 4 and factor it into
one and
negative
2. No.
-4 and 1. Okay, is it a removable discontinuity? Yes, because the x minus 4s can cancel. So my answer is yes, there's a discontinuity at x equals 4, and it is removable.
How
No, because it's only on the bottom. We only care about the bottom being 0. The top can be 0 all at once.
So you get 4?
Yeah.
Okay.
How do you get 4?
Mary?
So when there's like, say.
No, 4 minus 4 equals 0, so that makes the discontinuity.
Couldn't, yeah, you
Okay, yeah, I
can't
got
cancel them, so if there is a discontinuity, it's not
on
going
top
to
of
be
the
removed.
parentheses.
Where it says x equals 4, how did you get that?
That's because you weren't paying attention.
Because that's the discontinuity.
Okay, but you're a sign. Oh my God.
So x equals 4.
Are you gonna?
Okay, remember, I don't care what the problem asks you. Okay? I want you to answer 3 questions. Continuous or discontinuous? If it's discontinuous, where? And then what kind of discontinuity is it? Okay? So we're not doing domain and range and intercepts and asymptotes and all that kind of stuff. We're not graphing. Continuous or discontinuous, where, and what kind?